I work in Cranfield, which is nearby, and we have an airport which is fully functioning, and we do a lot of things with hydrogen, and we don't have any undergraduates, but we have a lot of master students and PhDs. We're number 28 in the world's top 30 engineering universities, and we are quite proud of that because we're very small. So we play around with a lot of things, and I have spent a lot of time in different industry sectors before I went to academia, and I get involved into the value of data, valuing a data set, including its environmental impact, by the way. A lot of data is actually junk, and we are afraid to delete it because of the fear of possibly missing out something from it. We will probably end up leaving this world without really knowing how much data junk we leave behind. But because we can't see it, we don't know how much it is. But it does hurt the world. It has emissions, although it's very low, as we heard earlier on today. I also teach manufacturing strategy. And I think one of the problems with technical people is we usually find out technology and we're looking for a problem. And then we have marketeers who have a problem and they don't know what technology to use, and the two never synchronize each other. That's a bit of a problem because what's the way for return on investment in the long term? Because that's what manufacturing is all about, that's what print is all about. What is the way? By the way, the strategic task of manufacturing is this simple sentence, in my humble opinion. What are we there to do? To make a good return on investment over the long term, which benefits stakeholders, shareholders, employees, local communities. So is there an ROI? Is there a return on investment in AI? Because if there isn't, guess what? No one's going to invest in it. And what is the trade-off? Okay, let me see. Quality and throughput, trade-offs, right? Can you have perfect quality at what trade-off? In your speed, in your throughput, in your sold units coming off your press or your factory. And we have this curve that we call in strategy the efficient frontier. It's usually a curve. If you're off the curve, you have to decide what you need to do to get back on the curve in terms of investing in technology, processes, fixing things, improving things. And yes, you might have a print company in Z, where their technology or their practices are as good as C, but the throughput is lower than C. So they need to figure out what it is that keeps them there and get back on that curve. Okay. Well, I'm going to talk to you about a use case, because there's nothing better than use cases. What I would like to encourage you all is to figure out good use cases for AI, otherwise there is no ROI. If there's no ROI, don't waste your time on it until such is the time to focus your time on it. This is my daughter. She's battling stage 4 cancer right now. It's been a shock to me and my family. And she is wearing, she has a PICC line that takes battering ram drugs into her heart, which is chemo drugs. Doxorubicin is that really terrible drug that a lot of people have for breast cancer and other cancers. I hope you never have to experience it. It works, but it's very unpleasant. And what I'm showing you there is it has a very sophisticated wound dressing on her arm. That is very sophisticated because it has to keep this line in place, and it has to be there in a way that it remains intact so it doesn't get contaminated, because if it gets contaminated, she'll end up in A&E and she will have other complications. So something very simple. And why am I talking to you about this? Because print is related to converting, right? Print is related to converting and packaging. And you can see here, and I borrowed this image from a very, very nice SME, which is very enlightened. And there are a lot of sophisticated wound dressings. Novalia, you probably need to get involved into this. Talk to me about it. Where are you, Chris? Chris gone. He's gone. Okay. And this is a converting line that makes a lot of a lot of wound dressing like labels, something like that. And I have some I can show you at lunch. So this is a dedicated line in the clean room, and you can see the wound dressings being made there. They're not very fast lines, but there's a lot of sophisticated polymers being converted and cut in a specific shape. There is a pad on a pad, and there's liners. And they are medical things. They're not cheap things to make. And here we are. A QC problem. At the end of that line, there's usually a human being taking this, putting it up against the light, and checking front side, checking back side, sometimes measuring it. And they're looking for the needle in the haystack. So you see there is one there that has a tiny little dot. So what? So what? Well, that tiny little dot, remember my daughter? It could harm her. It could harm any of your loved ones. It could harm you if that person doesn't check that wound dressing with their eyes. Of course, after they do that, these dressings go to become sterilized in a gamma irradiating facility somewhere in the country. There's not many of them, by the way, but they all go there. But before they go there, these things cannot go into the good product bag or bin. So, I work in a university, I understand a little bit of machine learning, I understand a little bit of code, I have a lot of very sophisticated, clever students working with us, so we thought, meet Dancer and Miller. We have a couple of desktop robots, and we thought, what if we could use machine learning to dynamically teach the algorithm to recognize defects, tiny little dots, like 500 micron, half a millimeter, on these wound dressings. So a person doesn't have to do this all day long in a clean room. And then do it so well that we can convince the licensing authorities that this setup can do it better than a human. Because if we don't convince them, they will never give us a license. This is a fantastic niche, by the way. Remember that ROI? ROI manufacturing will never happen doing easy things. Not in this country. Only difficult things. But my ambition, our ambition in Cranfield, is that this shouldn't be difficult. So look, anything that I've got there, you can have. For not a lot of money. And you can take the Z company to give them an efficient frontier that's better than C, even. Why? With a little bit of technology, which is probably on that table, I have a technology that's worth less than £50,000. And that's how you get ROI manufacturing today with machine learning. Where's the machine learning algorithm? I didn't code it. I'm just using something that someone's made for chocolate biscuits. It's on the cloud. I don't really need to know what's under the hood of the car. All I just need to do is get some sample of those dressings, label them so that I teach the machine algorithm to recognize what bad is. Okay, remember that dot? That dot could be anywhere. So the machine learning algorithm, all it needs to know is show me a bad dot, bad color dot, bad size dot, do some crazy dots just in case they manifest themselves, and just do it again and again and again and again and again to validate it to a coefficient of the variation that's very, very low, so I can convince the Food and Drug Administration to give us a license. Or rather, to allow us to make a change to go from a human to Miller. By the way, I probably need only either Dancer or Miller, not 2 robots, probably 1, to get to a new efficient frontier curve. And you can then begin to imagine, if I can do that for a 0.5 millimeter dot, they can do it too. They can do it too. Oh, the breads. They probably can do that too. And something that would be very familiar to you, could it do that? By the way, if there's a tiny 0.5 millimeter dot there, no one's going to die. No one's going to die. So is that going to bring you to an efficient frontier? What I'm saying to you is, and I was talking to a wonderful lady at break. Sometimes we try the old sledgehammer to crack a nut. That little dot that can put someone in hospital and lead them to a grave, it's a good problem to solve. That 500 micron dot that no one's going to see, maybe not so much. Because it's not going to give you ROI. It's not going to make you go faster, will it? But if it did, great. Because ROI is what keeps manufacturing alive. Sometimes technical people get too enthralled with technology. Then we look for problems, and we find some that are not worth solving because they're really small. By the way, again, over break, we were talking how I know that advanced statistics is far more efficacious and faster than some of the stuff that AI can do. Some of you have said it already, and why complicate something if you don't need to? But vision control systems on high value, high stake products, machine learning opens up a whole new door and reduces the price. All it needs is a little bit of inspiration, so hopefully I have shown you that. This is primed for this application. Nothing to do with print, of course, but you can imagine what's going on here. How a vision system, simple vision system with a robot and a machine learning algorithm can look what's going on there. So that's the way. These are the things that the trade-off curves are. The efficient frontiers, you can create a 2x2 using those very important elements in manufacturing. If you are not talking about any of those, then you're probably trying to solve the wrong problem. Thank you.